Zero Fuel is a new fuel that is based on dissolving urea in water. It is non-toxic, it's not explosive, it's not flammable, and the reason we call it Zero Fuel is actually, if you look at the Department of Transportation, they have these diamonds that specify what chemicals are, and they rate the hazards anywhere from 0 to 4, with 0 being the best. And in all 4 categories, Zero Fuel gets a 0. So it is the safest fuel. It's far safer than gasoline or any other alternative fuels that have been proposed. Urea is actually used as a fertilizer. It's its biggest use. So you have farmers putting it on the ground all the time, and it just makes the plants grow faster. Some people sometimes are confused because it's a fertilizer. It is not the explosive fertilizer. It is perfectly safe, and as a matter of fact, we'll show you later a demonstration. The urea is also less toxic than even salt or baking soda, and so if there's a spill, there aren't any problems. We feel it is the safest alternative fuel. Urea fuel is also the only alternative fuel that's actually cheaper than gasoline. Currently, urea is made from natural gas, and if you look at a long-term history of the price of natural gas over 30 years versus gasoline, although the percentage varies, natural gas has always been cheaper than gasoline. So in terms of dollars per BTU, making urea has always been historically cheaper than making gasoline. So consequently, urea is actually cheaper fuel than gasoline. This is one of the things that's held back a lot of other alternative fuels. Hydrogen, for example, a lot of people have been talking about, and a lot of people don't realize though that the current price of delivered hydrogen is something on the order of $20 per gasoline gallon equivalent. So most people wouldn't be happy to pay that, since they were complaining about $4 and $5 just a year or so ago. So it's very important that we feel that this is a market-based solution, that the cost of urea will incentivize people to want to use it. And urea saves costs in 2 ways. First of all, it saves in the actual operational cost, because the fuel itself is, like I said, made from natural gas, but because of the nature of the fuel, we can increase the compression ratio of the engine, which increases the efficiency of the engine. So not only are we using energy that's costing us less dollars per BTU, but we're getting more out of that BTU than a conventional engine. So you have 2 things going for decreasing your cost per mile, which of course is the bottom line. That's what you're really interested in. So the cost per mile for the urea is less than any of the other fuels that are being proposed out there. It's also cheaper because the car itself can be made cheaper. The big saving is that since this is not a carbon-based fuel at all, but in point of fact ammonia is going through, you don't need the catalytic converter. The catalytic converters in the cars use very expensive precious metals such as platinum and palladium and rhodium, which are truly scarce metals in short supply. This eliminates the need for that catalytic converter, and essentially the rest of the changes to the engine are minor, and something that when done at the factory would basically have little or no cost differential from a conventional engine. So consequently, you have a better performing engine for less total dollars, and it will be a cleaner engine as well. Zero Fuel also has several other markets besides cars. As a matter of fact, there's excellent opportunities in heavy machinery, equipment, trucks, mining equipment, construction equipment. It's well known, if you're in the construction industry, for instance, to run a bulldozer all day is like running 500 cars, and they have the fuel bills to prove it. So if you could save money on that fuel bill, that is a big advantage. Another big advantage is that right now the EPA is starting to crack down on the emissions of a lot of these diesel engines, and it's a big problem for both the diesel manufacturers and the construction industry. The construction industry, people don't want to commit to buying a piece of equipment that normally would last 10 or 20 years if the EPA is going to change the rules in 3. So they end up wanting to lease the equipment, but that's not good for the manufacturers, because what do they do with the leases? So they need a clean fuel. Urea will be that clean fuel. That clean fuel if used in place of diesel fuel, would obviate all the emissions problems that the heavy equipment has. This is a huge market. It's a very important market. It is a large source of pollution that could be eliminated by switching to the urea. Another thing is that in heavy equipment, there is, again, just like in traveling, there's the danger that you're working around dangerous areas. You'd prefer to have a fuel that's not flammable in the case of any kind of accident. The accidents are bad enough, they don't need to add fire to it. Again, the fact that urea is not flammable would also be an excellent safety issue as well. Okay, we're going to show you how simple it is to make some zero fuel. First of all, the key ingredient in the fuel is urea. As you can see, we just buy 50-pound bags of the urea, and as a matter of fact, we just scoop it out, and you can see it's just these white prills, and very safe material, non-toxic, nothing to worry about. And normally I would measure and weigh this, but to show you how simple it is, we're just going to take some water from here. So we just take some warm water, and essentially all you have to do is just pour it in here with some stirring. As you can see, just like dissolving sugar in water, it just takes a minute. And there you have it. And it just looks like clear water. And as a matter of fact, then this is what actually goes in the gas tank of the car. And essentially, when you need the fuel pump pumps it over this catalyst right here. This catalyst turns it into ammonia, and the ammonia is what's burned in the engine. And it's as simple as that. It's safe, it's clean, and it's cheap.
We're here at Bayshore Recycling to do an experiment, and the experiment is to make a 1-liter engine run on ammonia as a fuel instead of gasoline or diesel. This machine here is the device that we use to generate the ammonia. If we go through the sequence of events, this plastic container contains 50% urea and 50% water mixed together. Is it attached to a pump? The pump feeds this line into this bonnet of steel. Inside this reactor vessel is a coil of stainless steel tubing attached to a reformer. Inside the reformer is a proprietary metal that we use to turn the urea into ammonia. That runs through here, and if you notice down here we have a heat gun which will simulate the exhaust of the engine when we build this into the car. This heat gun gets to about the same temperature as the exhaust, so we use this to generate enough heat to simulate the exhaust going through the exhaust pipe out to the back end of the car. When it gets up to a certain temperature, the urea is turned into ammonia. It comes out of this tube into this check valve into these storage tanks. The storage tanks hold the ammonia until we're ready to use it. After we reach a certain pressure and temperature, we inserted this plastic tube into the intake of the fuel injection system, which is where the air goes into the system, not the fuel itself. Fill the car. Got you rolling?
And then I'll work off your cue.
Okay, turn it over. Running on ammonia. The car's running on ammonia. We're losing pressure pretty quickly. Got the valve all the way open.
Timing all the way in.
It did run on ammonia to the perfect point.
That's it. We got that. It started on ammonia, which is the high side.
Yeah. Cut the pressure.
Gas off?
Gas is off.
All right. want to see something. So to make sure it was going to completely run out of fuel, you know what I mean? Alright, man, we'll do a run test and then we'll see how far.
50 pounds.
Is that a lot? The mic, maybe? So that run out? What did we get? Then on the third test, if we did actually achieve a run from idle, we wanted to give it some air and see if we pick up RPMs. Okay.
We're out of fuel.
All right.
Oh, it didn't work now.
Yeah, it worked. Started right up. Settles that.
You got it. You got it. That's it.
Yep.
Excellent. Thank you. We were able to run the car, the engine, the 1 liter engine, and accelerate it at the same time for about 30 seconds, something like that. And that is basically the function of this machine and the simplicity of it.
AFS and zero fuel technology are very much the intersection of vehicle performance and the green movement. Zero fuel and its derivative ammonia gas have more octane than gasoline, uses existing engines, produces zero emissions, and is less expensive than diesel fuel. And most importantly, it's viable today. We will devote our time, know-how, contacts, capital, and other valuable resources to ensure the absolute success of this noteworthy project.